So now we're working on test 10, section 5, numbers 13 to 16, and this starts on page 968. So now we're moving out of the mediums into the difficults. 13. The figures above represent 3 pieces of cardboard, so I'm going to have to try to draw this. So it looks like this. This is not going to be exactly to scale, but you get the point. This is length 1, and I like to think of this problem as Tetris. Figures above represent 3 pieces of cardboard. All angles of the cardboard pieces are right angles, all short sides have length 1, and all long sides have length 2. Okay. Which of the following figures could be made from only the 3 pieces of cardboard without overlapping or cutting them? And then they give us 3 choices. First one looks like this, where they tell us that this is length 3, this is length 3, and this is length 2. Alright, so this is Roman numeral 1. And let's just do A, B, C, D, E. We're going to do none, 1, 2, 3, 1, and 2. They want to know, alright, which one of these figures can be made from taking these guys and laying them into the figure to see which one of these can make the shapes here. This shape. Which of these 3 shapes, when they add it up, when they're put together without overlapping or cutting, can be put into these shapes. So let's start with this plus sign, because that's going to be pretty much the key to determining if these are going to work. So we lay the plus sign in here, and it's going to look like this. And how do I know it looks like this? By the measurements. Because I know that this is length 2 over here, which means this is going to be length 1. This is length 1, length 1, length 1, length 1, length 1, length 1, length 1. You know by the dimensions that it fits in like this and no other way. So what's going to be left over? Well, just these plus. So I can put this square in here, but notice this L shape I can't fit in. So 1 is not going to work. So I can get rid of anything with 1 in it. So that'll be B and E. Let's try out 2. So 2 looks like this. It's got length of 4 over here. It goes up like this, juts out like this, and goes like this. And they tell us this is length 1, this is length 2, 2, 4, 3. Oh, no, they don't tell us 3. Sorry. I'm looking at the wrong one. 4, 2, 1. Right. So let's do the same thing. Well, we know that we can fit our plus sign in here, right? Because this is going to be 1, 1, 1, 1, 1, 1, 1. Then look at that. We can fit our box in here, and we can fit our L shape in here. So this one's going to work. So anything with choice 2 in it should be kept. Anything without it should be gone. So we can get rid of D. We can get rid of A. So C is going to be our answer. If we tested number 3, you'll see it's not going to fit either. You can't even fit this plus sign in for number 3. So that's not going to work. And we also know that by elimination, but just if you wanted to check it. So the answer there is C. 14. How many integers greater than 20 and less than 30 are each the product of exactly 2 different numbers, both of which are prime? So the best way to do this one is just go through all the numbers between 20 and 30 and see which ones are going to be equal to 2 different numbers multiplied that are both prime. So 21, that's just 7 times 3, right? Those are both prime, so 21, cha-ching, works. 22, well, that's just going to be 2 times 11, right? Are they both prime? Yes. Remember that 2 is prime. That's the big thing. 2 is the first prime. As a review, 0 is not prime, 1 is not prime, 2 is prime, 3 is prime, 5 is prime, and so on. A prime number is a number that can only be divided by itself and 1. So 2 is always prime. 23. Well, 23 is just itself prime. It's 1 times 23. That doesn't work because 1 isn't prime, so we can get rid of it. How about 24? Well, that's just times 6. 6 times 4. No good. 25? That's 5 times 5. Well, they're both prime, right? Well, they're not different. They're the same, so we can get rid of 25 for that reason. 26 is 13 times 2. Aha, that works. These are both prime. 27 is 9 times 3. No good. 9 is not prime. 28 is 14 times 2. 14 is not prime. No good. 29 is 29 times 1. 1 is not prime, so 29 is no good. So that's it. The answer here is 3, or choice D. Now we are on to number 15. Figure not drawn to scale, so I will draw this out. That's not very good. It's very hard to draw with this pen, draw these diagrams sometimes. Okay, that's good enough. We're told this is 7 minus x, this is 10, and this is 7 plus x. Figure not drawn to scale. The figure above is a right triangle. What is the value of 49 plus x squared? I'm not sure why the figure not drawn to scale here matters. I'm not sure what would trick you. But anyway, we want to know what 49 plus x squared is. That's really weird. Why would we want to know that? Well, let's go ahead and do this. Let's do the Pythagorean theorem, because that's a formula we'll be able to set up. So we do the Pythagorean theorem. That's a squared plus b squared equals c squared, and that's in your little chart at the front of the section. Well, a is just going to be 7 plus x squared plus 7 minus x squared equals 10 squared. Let's unfoil these. We get 49 plus 14x plus x squared. If you don't see how I did that, just do the FOIL with these two guys. Do 7 times 7, 7 times x, x times 7, x times x, and you'll get this. Then we got to FOIL this. We're going to get 49 minus 14x plus x squared. That equals 100. Well, we can do some elimination here, right? 14x and minus 14x are going to go. We can add these together. We'll get 98 plus 2x squared equals 100. Let's divide both sides by 2. We're going to get 49 plus x squared equals 50. And wait a minute, 49 plus x squared. What do you know? That is what we were originally looking for, right? The beginning of the problem. They wanted to know, what is 49 plus x squared? Well, here it is. 49 plus x squared is 50. That's choice A. The other way you can do this is you could plug in the answers. Say, okay, 49 plus x squared is 50, which means x squared is 1, which means x is 1. And then go ahead and plug that x into the sides, and then do the Pythagorean theorem and see if it works out. A little bit roundabout. You get lucky because A does work first. But I think the more direct route is doing the algebra in this case. Usually plugging in is easier. I think not in this case. It is not. Last one, 16. The figure above shows the graph of a quadratic function h whose maximum value is h of 2. Alright, so let me write this out. The problem is I've written on my book so much I can't remember what they give us. I don't think they give us much of anything. I think they give us that this is 1, and this is negative 1, and that's it, right? And then they give us this figure like this. Okay. My picture might be awful, but we'll see what happens. So whose maximum value is h of 2. So this is the maximum. So we draw down the maximum. This is going to be 0.2. If h of a is 0, which of the following could be the value of a? And they give us a bunch of choices. Well, h of a is going to be where the function equals 0. So it's going to be either here or it's going to be here. And this is actually a really terrible picture. This should probably be more like this. Okay, let me see if I can erase this. And I can. Good enough. Alright, so here, I'll just touch this up. Alright, so, and then it's either going to be here or it's going to be here, right, where it touches the x-axis. So we want to figure out what is the x value of one of these points, and then we'll be good to go. So, the one thing to remember about quadratics here is that they're symmetrical. What happens on one side happens on the other. So if 1 is here, then we have a point here, 3, which is, the same distance away from the turning point as it is from 1. So they're right here. Well, let's go over here. Here's 0, and it still hasn't touched the point here, right? It's still underneath the quadratic. So that means we have a point here, 4, which has not touched the quadratic. So knowing that, we look at our choices here, A, B, C, D, E. Let's look at A. -1. Well, we still don't know anything about that. We'll leave that. B, 0. Well, we know 0 is here. It's not going to be where the minimum is, or I should say where, not the minimum, but where it hits the axis, right? It's over here. Here's 0. So we can get rid of B. That's 0. No good. How about C, 2? Well, no. We know 2 is the maximum. That's not going to be where it equals 0. That doesn't make sense. D, 3. Well, again, by symmetry, we know that if 1 is here, it's still under the parabola. 3 is here. It's still under. It's not at 0, so no good. How about E, 4? This is the key one. 4, by the same argument, is still here, still under the parabola, still waiting for it to come down and hit 0. So 4 is not going to be answered. So the answer is going to have to be -1. So this point is probably -1. It could, I guess it may not necessarily be, but that's one of the choices it could be, because that's what the problem was. What could it be? We know the other 4 it can't be, but we know it could be -1. So the answer here is going to be choice A.